Welcome to today's math lesson. We're going to be looking at section 5-3, solving trigonometric equations. I believe this one is going to be spread out over 3 videos. Our bullet points: use standard algebraic techniques to solve trig equations. Solve trig equations of the quadratic type. Solve trig equations involving multiple angles, and use inverse trig functions to solve trig equations. A lot of the stuff you're going to see in here, we've kind of seen before with algebra. We're just going to splash it with a little trig. Very similar to some stuff we're going to be seeing shortly. Here are some algebraic equations, dealing with x's and numbers. So, just as a refresher, if I add x to both sides here, I'm going to have 2x on this side, and this plus x squared, I'm going to subtract that. So now on the other side, it's going to be a minus root 2. And then if I solve to get x alone, x is going to equal the negative root of 2, and we're going to divide by that 2. So there's our x value. When we're solving for x, we're just getting the x all by itself. Or for this one here, let me give myself a little room. I'll work upwards here. First step I would do is add 1 to both sides. Oops. Equals 1. And then I'm going to get the x squared alone by dividing by 3. So that would be 1/3. And then I'm going to square root. I'm going to do the numerator and denominator separately. So x would equal the square root of 1 is 1 over the root of 3. And of course, we want good math manners. Ooh, and I forgot my plus minus. That was a close one. We're going to rationalize. Multiply top and bottom by root 3. So root of 3 over 3. Positive and negative. Again, those are algebraic ideas for solving for the variable x. We're going to do something very similar now, but we're going to solve for a trig value. The sine of some angle, in this case, is a half. We'll figure out what angles make that happen. So the introduction: to solve a trig equation, use standard algebraic techniques whenever possible, such as collect like terms, extract square roots, and factor. Your preliminary goal in solving trig equations is to isolate the trig function on one side of the equation. For example, this equation 2 sine x is equal to 1. Divide by 2 and we obtain sine of x is equal to a half. To solve for x, note that the graph of y equals sine x below is more, or that the equation sine of x equal to a half has solutions at pi over 6 and 5 pi over 6. If I bring up real quick, I think I got a unit circle here. Boom. Sine x is equal to a half. We know from studying the unit circle that sine values are y values. So I'm going to start looking at my y values until I see positive a half at pi over 6, and also over here at 5 pi over 6. So, and then to write the solutions, remember we can do infinitely many trips around the unit circle. We're going to take that first one, x equals pi over 6, and then say, well, if we add another 2 pi, we'll get right back to where we started. And then they say here this n stands for some integer, some positive whole number. And then we also have our other answer, x equals 5 pi over 6. And we could say, well, there's infinitely many more answers, so we're going to add a 2 pi times some number n. Okay, that is our general solution. We have infinitely many, this angle plus trips around, and then another angle plus infinitely many trips around the unit circle. And here's what that looks like if we unwrap the unit circle into the sine wave. Again, that sine wave goes infinitely far in either direction. And, here's our line, y is equal to a half. So the graph is going to periodically bump up, hit the line, and then go above it and hit it again on the way back down. It's going to do that infinitely many times, hence our need for that plus 2 pi. All right, here we go. Example 1. The collecting like terms technique. So first, I see this negative sign. We're going to add sign to both sides. So now that's going to be a 0. And we have a sign over here. And if we add another sign to it, we now have 2 of them. 2 sine x plus root of 2 is equal to 0. Well, now our goal is to get this sine x by itself. So our next step, obviously, we're going to subtract that root of 2. On the other side, it will be a negative root 2. And now we're to get the sine x all by itself. We're going to divide both sides by 2. So what we have is the negative root of 2 over 2. And it's time to take a trip to the unit circle. Remember that sine values are y-coordinates. So if our sine value is a negative value, we're just going to be looking in the bottom quadrants. And we're looking for a y value of negative root 2 over 2. Here's one of them. I'll circle that one in blue. And then over here is another one where our y value is a negative root 2 over 2. And that occurs at 5/4 and 7/4 pi. Ooh, and let me point out here, if we look across the unit circle, from the red one, this one over here is not an answer. And then this one over here is not an answer also. And you'll see why I'm pointing that now. That's going to bear fruit a little bit later. So again, 7/4 and 5/4, they are not across from each other on the unit circle. These two answers are not on the same diameter. So to write our answers, we'll write that x equals 5 pi over 4 and also x equals 7 pi over 4. There are two of our answers, but there are infinitely many more because we could add a plus 2 pi n to either of those. Oh yeah, and earlier they said n is an integer. That includes the positives and the negatives. So we don't need a plus minus here. We just, this n could be a positive or negative whole number. So here are the infinitely many solutions to our original equation. Next technique, extracting roots. To extract roots, we've got a squared term. We want to get the squared term all by itself and then root both sides, and that is the extraction. This should look vaguely similar to one of the warm-ups. So 3 tan squared minus 1 is 0. Step 1, add 1 to both sides. 3 tan squared x is equal to 1. Divide both sides by 3. Tan squared x is equal to 1/3. Now we are going to take the root of both sides. So the tan of x equals, the square root of the numerator is going to be a 1. The square root of our denominator is going to be a root 3. And do not forget the plus and minus. Okay. To actually find the values that will be on the unit circle, let me move this up here. We are going to rationalize. So top and bottom are going to get multiplied by a root of 3. So our tan of x is equal to plus or minus the square root of 3 over 3. Okay, now the plus minus actually means we're going to have 4 solutions. And I'm going to do it like this, move this up here. So tangent is either positive or negative root 3 over 3. I'm going to go to a unit circle on the next page here. And tan is equal to root 3 over 3, positive at pi over 6. It's also equal to the same root 3 over 3 positive at 7 pi over 6. And then it's equal to a negative root 3 over 3 at 5 pi over 6 and also at 11 pi over 6. Now, to write my solutions, let's see here, I'm just going to stick with the black ink. We could write x equals, ooh, and let me just erase this so I have plenty of room. So x is going to equal pi over 6 plus 2 pi n. And x is going to equal 5 pi over 6 plus 2 pi n. And then also x equals 7 pi over 6 plus 2 pi n. And finally 11 pi over 6 plus 2 pi n. We have 4 solutions and infinitely many when we take more and more trips around the unit circle. But notice this. Some of the answers are directly across from each other. If they are directly across from each other, we would just do a 1 pi rotation to get there. And if I'm at 7 pi over 6 and I add another pi, it'll take me back to the pi over 6 angle. So if 2 of the answers are directly across from each other on the unit circle, we can combine them down to the lower of the angles. In this case, it'll be pi over 6 plus not 2 pi n, just 1 pi n. So we can condense them down because they are straight across from each other on the unit circle. Same here, if we are at 5 pi over 6, we could do 2 pi and go all the way around. Or if we add 1 pi, we'll get directly across the unit circle here, add another pi, and that will take us back to where we started. So once again, these two are directly across from each other on the circle. We can combine them down to the lower value, 5 pi over 6, plus 1 pi n. All right, oops, wrong way. There we go. Let me see what this remark says down here. When you extract square roots, make sure you account for the positive and the negative. Duh, we knew that. Okay. A couple for you to try on your own. Notice in the first one, it's signed to the first. This will have two solutions with infinitely many more coming after them. This one here, it is squared. So when you extract the roots, don't forget the plus minus, you'll have four solutions. And if they're directly across, you can combine them. So pause the video and try the problems and start it up and see if you got them right. First one here, very similar to our example. We're going to add sign to both sides. So now on the left, we're going to have two of these signs. And then here's a negative root of 2. We're going to add that to both sides. So now it is a positive root of 2. And then we are going to get sign alone by dividing by 2. So now we have root 2 over 2. And these are positive. I believe in the example they were negative. So now we are in the top two quadrants. Where is our y value equal to root 2 over 2? That occurs at pi over 4. And also at 3 pi over 4. So there are the two solutions that come from one trip around the circle, but there are infinitely many more if we multiply or add or subtract a 2 pi n. More trips around the circle. Okay, here we go. So I'm just going to do sort of all this in one step. We are going to get the sine squared alone. So here's my sine squared and my equal sign. To get it alone, we're going to have to add 3 to both sides. So now it's a plus 3 on the other. And then we're going to divide by this 4. So that's 3/4. And we are going to take the square root, the sine of x equals. Don't forget the plus minus. Our numerator is a 3, so that'll just be a root of 3. Denominator is a 4. The root of 4 is 2. So sine is equal to either positive or negative root 3 over 2. And I'm going to do this just so I have plenty of room. Put my unit circle on the next page. Sine is root 3 over 2. So here, my sine value, my y value, get over there, what's going on, is root 3 over 2. Same thing here. Oops, getting some glitches on my path. Root 3 over 2 negative down here and down here. Now notice the ones I've circled are straight across from each other. Getting more glitches on my software. There we go. So the ones that are directly across, we can combine. So let's look at our angles. We've got 1/3, 2/3, 4/3, and 5/3. So I'm just going to list all of those out. So x equals 1/3, 2/3, 4/3, and I guess I need a little more room. I can get rid of this because you have it written down in your notes. And x equals 5/3 pi. Now each of these would have a plus 2 pi n. I'm just going to save my time copying and writing that down. And remember, the ones directly across from each other are able to be combined. So I'll use red ink for this one. That's going to be the pi over 3, and straight across from it is the 4 pi over 3. So we go with the smaller, the pi over 3, and we're going to add not 2 pi n, but a 1 pi n. Now the 2/3 is directly across from the 5/3, so they're going to combine to the 2/3 pi plus 1 pi n. We've taken, what we'd have to write down 4 times, and we've condensed it down by changing the 2 pi n to a 1 pi n. Okay, good times. Our last example, I believe, for this video. And it says the equations in the first 2 examples involved only one trig function. When 2 or more functions occur in the same equation, collect all terms on one side and try to separate the functions by factoring or using identities. This may produce factors that have no solutions, as we are about to see. Now, when I look at this, I see a cotan x on the left and a cos squared x and a cotan x on the right. Do not divide by cotan x. If you say, I'm going to divide by cotan x, do not write this down, and we cancel it out, what we have done is thrown one of our possible factors into the garbage. We may have thrown good answers, good solutions, into the garbage. We're never going to divide by some variable quantity. We're going to set it equal to 0 and factor. So let's subtract that term on the right. So we've got a cotan x times a cos squared x, and now it's going to be a minus 2 cotan x, and the whole thing is equal to 0. Now, if I imagine some brackets around there, I can factor out of the brackets a cotan x. And what's that going to leave me inside? A cos squared x minus, we factored out the cotan, so that leaves us a 2. And that is equal to 0. So now, since we have multiplied factors equal to 0, we can set the first factor, cotan x, all by itself equal to 0. And then the other quantity, cos squared x minus 2, we can set that equal to 0. All right, now that we've got these equal to 0, I guess there's a couple ways we can approach this. Where does cotan equal 0? Well, remember, that would be a 0 over 1. So if we flip over cotan, that would be tangent. And if we flip 0 over 1 over, that's going to be undefined. So we can look on our unit circle where tangent is undefined. Or you could also remember that cotan is cos over sine. And where would, when a fraction is equal to 0, the numerator is equal to 0. So we could say, okay, where does cosine alone equal 0? And that's the same answer as where tangent is undefined. That is equal to pi over 2 and 3 pi over 2. And these would each have their own plus 2 pi n. But remember, let me make a new slide here and drop a unit circle on it. Remember, if answers are directly across, they can be combined. That always occurs when you have a cos squared or a sine squared and you have to square root. But in this case, pi over 2 is directly across from 3 pi over 2. So these two can be combined. We can just make it the lower of the two, the half pi, plus not 2 pi n, but 1 pi n. So here we've set our first factor equal to 0 and got some solutions. Let's go over to the other one here in blue. And if I take cos squared there and add 2 to both sides, we're going to have that's equal to positive 2. And if we take the square root, cos of x is going to equal the root of 2. So on the unit circle, can we find places where cos is equal to the root of 2? Where is our x value equal to root of 2? It occurs nowhere. Remember, the unit circle has a radius of 1. The square root of 2 is a number bigger than 1. I think it's approximately 1.7 something or 1.4 something. It's definitely a number bigger than 1. If you try to punch this into a calculator and do a cos inverse, you're going to get error. Root of 2 is too big. We have no values where that's going to be true, so all this led to a dead end. But we still got some good answers, so it was not all in vain. One more for you to try, so work on this one after you pause the video, and then fire it back up and see if you get it right. Step 1, I'm going to subtract a 2 sine x. 2 sine x. Now it's equal to 0. And I'm going to factor out a sine x. So if we factor a sine x out of here, that's going to leave just a sine x. And then this sine x has been factored out, so that leaves us a minus 2, and that's equal to 0. So now we can set this first factor by itself, sine x equal to 0. And where does that occur on the unit circle? That occurs at 0 radians and also pi radians plus 2 pi n. But 0 and pi are straight across from each other. They're only a half a circle away. So we can make that not 0 or pi plus 2 pi n. We can just say 0 plus 1 pi n. Okay, in the brackets, if we set this to 0, we're going to get sine of x is equal to 2. Remember, sine values are y values. Our highest y value is a 1. So they're asking for a value well off the unit circle. That is undefined, error, does not exist. Again, if you punch that into a calculator, like a TI-30, 2 and then sine inverse, you're going to get an error message. Does not compute. Okay, in class, we are going to do the following odd problems, and notice they are paired up with your even homework problems. If you miss class when we're doing these odd problems, just go to calcchat.com and look up our book. You can see these step-by-step solutions. If any of these numbers are in red in the book, then that means there is a video solution on calcview.com. So go visit our buddy Gabe and see if he can help you through the problems. And I'll see you in class.